this is a very happy occasion for me. David and I go back quite a ways. Of course, he's one of the real founders of many-body physics. And our time together goes back to those days. I came here in 1949. I was 25. David came in 1952. I'm 5 months older than David. And he had
and we're still children together.
And you know, he had done this work at Princeton on the many-body problem. And so that was really sort of the beginning of all of this type of thing, considering electrons in metals and the interactions of electrons with one another. Al Overhauser came here in 1951. And when Al came, he was a brand new PhD. He came from Berkeley, where he'd been a student of Charlie Cattell. He had calculated the conduction electron spin lattice relaxation time. And he felt someone should start looking at conduction electron spin resonances. And then shortly after that, he saw that if you could find that resonance, that in fact you could polarize nuclei with it. And this was a very exciting proposal, and so my student Tom Carver and I went to work to try to do that. Well, in 1953, the Physical Society met in Detroit. And David and I and a bunch of others took the train from Tolono up there. And David and I sat together, and he said, you know, I've been thinking about Al's thesis, which was very fancy calculations. And he said, I think I know how one can make those, calculate those things much more simply. He said, there's only one thing, I'm using an expression I'm not quite sure for its justification. He showed it to me. And I said, well, that's actually something from NMR. I know about that. And so we decided that we should write a paper, and by the time we got to Detroit, we had written a paper. And now, you may wonder how come that happened. Well, the train was the Wabash Cannonball. That gave us a special edge. Well, not long after that, I saw David in the hall one day, and he was very excited because he said that he had been looking at the theoretical expression for the spin susceptibility of conduction electrons, and that he had been able to use the formalisms that he'd been working on to calculate the many-body correction to the formula. And he said the trouble is that one doesn't know how to measure the spin part alone, because when you measure susceptibility, there's an orbital part, and I'm not sure whether one could do it. Well, it just so happened that for my thesis, I looked at electron spin resonance, and I happened to just automatically know what one could do. And so we did that experiment. Now, the thing about this was that this was the first time I really thought about many-body physics. When I came out here, I didn't know any solid-state physics. I came here because it was being set up, but I'd never taken a course in it. I hadn't even read Fred Seitz's famous book, but I knew about him, and I knew about his book. And I thought that I could start to learn out here. Well, this experience absolutely changed my understanding of what it is one should be looking at in solid-state physics. The idea that one, at a very fundamental level, was trying to understand the complexities of the fundamental interactions, what today we call strong coupling. That's what many-body physics. This just absolutely changed my view of what it is one should work on in solid-state physics, and completely affected my entire scientific life since that time. Of course, not long after this, David did his famous calculation with John about the electron lattice interaction. And then David left and went back to Princeton, and Leon Cooper came, and Bob Schrieffer. And then we have the BCS theory. David is the fourth member of the BCS theory. And of course, it was wildly, enthusiastically accepted by experimenters. and a lot of the theorists were terribly disappointed. And there were people who were raising questions about gauge invariance. And so in the summer of 1958, David was in Paris with Bob Schrieffer, and they wrote several papers which really looked at this issue, and I think a phenomenon called backflow and current that we talk about when a charged particle is moving through a lattice, and basically resolved the issue. Well, I was in Paris that summer because there was an NMR summer school which I was asked to lecture at. So I was there with David and Bob, and Leon Cooper was there. And Bob Schrieffer had a wonderful new, I think it was a Mercedes-Benz convertible. And we all would ride around Paris in it. Leon Cooper in particular on one occasion said, we've got to go out to the Bois de Boulogne and have framboise, because he said, I forget who the famous French author was who had it there, and we had to live this experience.
Probably Proust.
Probably Proust. There you are. So I mean, we just had an absolutely terrific time. I mean, what I just want you to realize, I mean, we were really just kids, weren't we? and we just had a marvelous time. Well, I've benefited from this interaction with David for years, and David and his graduate students and his postdocs. And this has just been such a special thing. And as Paul has remarked, and Dale and Tony, it's the style of physics, the intimate interaction with experimenters has just been, for me, such an enormous boon and benefit. You know, David is going to give a talk tomorrow, and he's going to be talking about some of the stuff that he's doing recently. And I just wanted to read to you the last line of the paper, which I'm one of the 3 authors, which just appeared. And the final line is, the form of the results agrees with that recently proposed by Darcy and Pines. So this is what it's like, and it's just marvelous that you got this award, and all of us who learned so much from you. Educate us. You're our teacher of theory of solids and physics of solids. We just congratulate you, David.
I'm really quite overwhelmed, and I would love to have equal time. I'm trying to devote a little bit of my talk tomorrow for that equal time, but let me here say thank you enormously, Paul, Charlie, Dale, Tony, and the whole point, I think, what you really are saying is that we were all kids together, we had a great time, we had really fun doing physics, and this is a remarkable place in which to do that. I think Urbana still represents, more than any other place in the world, a sense of community, a sense of people interacting with each other, and just taking the pleasure of the joint company. And Robert Oppenheimer, I think, put it very well, how we go about this interaction between theory and experiment. He did it in a slightly different context. What he said is, what we don't know, we teach one another.
Thank you all very much indeed for joining us. A special thanks to the staff of the Physics Department for hosting today's events, especially Becky McDuffie and Sue Lynn Hurdle, and enjoy the colloquium. Thank you very much.